Hello, hello, hello. Ready to tackle day 8, Advent of Code. There we go. VS Code all ready to go. Ah, forget that. Coordinates in the third dimension. Ooh boy. 40, okay. Junction boxes. Guess I gotta start reading. Okay. So So the first junction on the list, great. Save, focus on connecting pairs as close as possible according to the straight line, okay. But connecting two circuit, now the two are closest but are already connected. Three, the next two. Okay, what are you doing? Is it just connect the two and then find the next closest one to the two? Wait a minute. The 10 shortest connections, there are 11 circuits. Oh, okay. Multiply the size of the three largest circuits. Okay, well, this is definitely graphing stuff. Been there forever since I've done this, so let's at least parse the information out. So cost, boxes, data. Oh, snooze that. What? On the new lines and map each. What are we looking at? It's just three numbers. So L dot split on the comma, map to a number constructor. And then what we're going to do is just say const x, y, z. Is that what they call them? X, Y, Z. There you go. Then return X, Y, and Z. And then boxes is all of them. Awesome. So, well, this is a tough one because it's not really an example. It's a freaking story. Okay, save. Connecting pairs are closest to possible. But are after connecting them, since why three? Are these is this just the next third one? Okay, I think I kinda get it. Make the 10 shortest connections. So for let I equals 0, 0 I less than 10, I plus plus. It's definitely a failure of efficiency, but that's okay. It's a of boxes. For cost B of boxes. Basically, I have to find the ones with the shortest distance between them. Shortest 10 shortest connections. What am I doing to sort these? Hmm. Not seeing exactly what I'm aiming for here. It's a tough example. These are the two closest together. Man, that didn't make an easy example. Yeah, it's these two. Next, but aren't already directly connected. Next two are 9 and 805. Okay. Um, so basically, I think it should need to make a list of all possible pairs. Const possible connections right here. It's going to be A equal B, continue, not concatenate, continue, possible connections, push, A, B, there we go. And then I think what we want to do is, so we're not doing this in a 10 loop, we're just doing this on once. So format, possible connections, sort, A, B, oh, this is great. Two, okay, I should also be pushing distances in here. Straight line distance Okay, I think I've done this one. Distance equals AB. Yeah, I'm not gonna do this hard again. I have no intention of reinventing this wheel. Not even embarrassed. I'm gonna type that. There we go. These words hard, and then distance, that is A and B. There we go, and then just sort, return 1 distance minus 2 distance, and I just connect the top 10. So possible connections, actual connections. So it's technically a hash map. Well, it's a bidirectional graph. It's gonna be terrible. So just going through the top 10 possible connections. Possible connections I class A B equals this. So connections JSON stringify A equals JSON stringify B. Well, not equals. It'll equal the previous if it exists, otherwise it doesn't exist. So connections JSON stringify A or empty array. There you go. So we're building up an arrays. It's beautiful. It's gonna be the best graph thingy we've seen. Record of string to string array. We love that. And then when we look at connections, boom, we have this. It's beautiful and it's ugly. Now we need to do groupings. Is that right? And there are 11 circuits. Okay. Connected 1,000 pairs. Oh, this is. Oh. Yeah, that's what the actual problem is. 1,000. Okay, that's a tough one. Connection count number. So for my example, it's 10. Real one, it's 1,000. Oh boy, oh boy. Okay. Real one, apparently it's 1,000. Cool, 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 cool. So we have a bunch of connections. Now I need to do grouping. Like, I've not done this in a long time. Groups, and just going through them all. So for const key of connections. I'm trying to muscle memory remember how to exactly do this. It's not snapping together though. I'll just create arrays of arrays, and if I've seen them before, then they kind of join together. I need to look at connections. Try to get a no, not connection count. Try to get a visual snappery. So this one is connected to those two. So I just kind of like while loop, keep going through these until I run out of them. I guess that's it. Remaining equals connections. Well, it's technically this one. It's key. It's connections and key. There you go. While remaining dot length const next equals remaining dot up. There we go. No more infinite loop. Or const group of groups. If group has, there we go. We're gonna use a set. Very efficient. Next, congratulations, you just found your group. Or, stop, really. Let has group equals false. Group equals true. Not true resource usage, just true. Break. I'm not seeing the relations here being built, but I don't know. Oh, it's group, not groups. There we go. That helps a little bit. Next, don't worry, you are. Da, da, da. You're, you're a string array. Be cool. You're real. Oh, there you go. And then if not has group, congratulations, groups push. You just got a new group, which is next. I feel like this isn't working. Next you're supposed to be a string. You are a string. I'm pushing to groups. A new set. My bad. Set string group. I'm not seeing the connections being built, unfortunately. I've missed something obvious. Let's see what all the groups I got. An array of 7. Yeah, they're all empty. They're all alone. No one actually has any freaking connections. Wait, all of these are in the same group. Ah. I kind of mess this up. So what I do is I find this and I see if you have a group, and if you do have a group, congratulations. Okay, I find the group that this one's in, I add all these ones to it. That's the strategy. Got it. So there's no while loop here. There's none of that. There is this logic though. So groups equals groups. Find g dot has key. If not, I'll make this a let. Keybinds are still messed up. Not group, group. Cast group set. Congratulations with key. And then groups push the new group. No matter what happens, connections, key, group. Okay, I think that is at least going to build some stuff. Groups, okay. One. Well, that didn't work. There are 11 circuits. One with 5, one with 4, one with 2. Well, that didn't work at all. Be nice if I got a little more information here. Okay, what things are connected? Wait, am I doing this in the right order? I could have done this in the wrong order. Possible connections. What do we got? Distances. 316. Nope, these are the shortest ones. Okay. Yeah, and 380. Well, I'm trying to think. Would you get 380? How many do we have? 20. Maybe. Oh, A to B. I also have everything going B to A, so that's awkward. AI. A. Entries. I don't want bidirectional. I don't need entries, but slices don't exist. Yeah, okay, I don't actually need the entries. Drop that. Hopefully, this is a little bit better. Well, how many are there? Because that was what threw me off. I just need to look at A and B then. +1, 2. Okay, so +1 gives me skipping the duplicate one. Hey, that's more efficient. We love efficiency. I am definitely lost my touch for this one. That's okay though. So 190 possible connections. That gets us a little bit better. And yeah, well, that's duplicates. No duplicates, technically. Okay, we love it. We have all these possible connections. Connecting pairs are close together as possible. The 2, 162, and 425. Can't see them. 162, 425. Great. 162. 431. Okay, let's see if that happens. 162, 431. Great. 906, 805. Okay, great. 431, 425. Good. They're in the same circuit, so nothing happens. Okay. After making the 10 shortest connections, there are 11 circuits. Now, I attempted to count them all. One with 5, one with 4, 2 with 2, and 7 with 1. One with 3, one with 4, and a bunch of 2. What did I have done wrong? Okay, 162, 25, 431. These are all the ones with the direct connections, possibly. Are we never finding one? Okay, so we are finding one. We're finding exactly one. Feels wrong. Checking if it has it. If it has it, great. If it doesn't, we add it. This feels like it should be working. I could make this more greedy, like keep going, but I have all the connections. Do I need to do it bidirectionally? I will do it bidirectionally. B, A, B. There we go. Now it's bidirectionally. As expected. Okay, that kind of populates the same. I should be 1 through 10 or 0 through 9, yeah. Look at what connections we got. We have this one connecting to those two. 162, yeah. 425. Connecting to itself. That's dumb. Oh, I typoed. 425. Okay, connecting to itself. Why? Connecting to itself 3 times. That's my goodness. What have I done? A connects to whatever A was connecting to, and B. B connects to whatever B was connecting to, and A. All my symbols were wrong. Okay, now we have the duplicates removed. Yeah, a lot of one-off connections. Okay, let me understand. One circuit with 11. I wouldn't see that connections. Don't know, my grouping logic is not working. Well, this is going off a lot more now. 1 with 4, 1 with 5. 4, 5, 2, 2. No, still not happening. Okay, let me count up this one. Okay, so let me count how many this is. Connecting 2. Okay, so I'm just gonna knock this down. Boom, 1 connection. That's right, you have 1 group, 1 junction, 1 doohickey. A thing of 3 junctions if you connect 2. Good. Okay. A thing of 3 if you connect 2. That's good. The next 2 are 9. Okay. Which would... So highlighted. Great. And those 2 are now happy. The next 2 are 430 and 420. Because these are already in the same, nothing will happen. Okay, I'm expecting no group changes. As expected, no group changes. Okay. After making the 10 shortest connections. One circuit with 5, 1 with 4, 2 with 2, and 7 I have 3 with 2. I'll put this back. Possible connections are sorted correctly, right? Do we skip the one that does nothing? After making the 10 shortest connections. No, it said make the 10 shortest connections. There are 11 circuits. After making the 10 shortest connections, there should be 10 circuits. Do you skip one? 5, 5, 2, 2, 2. 5, 5, 4. No. What am I looking at? I am missing something obvious. What am I missing though? Close together if possible according to straight line distance. Okay, shortest distance between 2 straight lines. Yeah, it didn't give me trash, did it? X, Y, Z, square root, X plus Y plus Z. It doesn't differ A, B, B, A. Should be numerically identical. Yeah, numerically identical. That's what I expected. Okay, let me do something easier then. Great. Now there's only 2. Right? How many boxes? How many boxes we got? Wait, I got it's only 2. There we go. How many boxes we got? We got 2 boxes, which means possible connections. Well, 1 can only connect to 1, alright? Yeah, making sure that logic is happening. 3 possible connections. Well, I can't see anything. But yeah, 162 connects to 57, 162 to 906, and then 57 to 906. Not 906, 57. Yeah, okay, so I'm generating the correct number of connections. That I'm confident of. Let me give you all your boxes back. Bringing the ith possible connection. I don't think I need the distance, but hey, I'll look at the distance. The distance, not the displays. Exactly what I expected. Small. Did I get bigger? Am I supposed to do something with the connection that does nothing? Am I not doing connections? Maybe that's our problem. I'm bad at connecting things. I say this is a directed graph. A connects to whatever A was connecting to before, and B. Seems good. I'm saying 162, 817 connects to this thing. JSON stringify stable. Last I checked. What have I gotten wrong? I have a lot. I do have a lot of quote noise with the bidirectionalness, but that shouldn't be problematic. It's just noisy, but I'll get rid of it. Do I actually have to visualize this to understand it? I don't want to. Okay, the 10 shortest connections. Don't do that with that one. Oh, I put that there. There we go. Thankfully, most of these are identifiable. So 162 to 425. Congratulations. You're connected. Who's the next one? 162 to 431. Congratulations. You're connected. 906, 805. Congratulations. You're connected. 431, 425. Congratulations. You kind of were already connected, but you're connected. 862, 984. Congratulations. You're connected. 52, 117. 819, 941. What's the other? Come on, give me the other number. 941. Congratulations, you're connected. 906, 739. Ooh. Welcome to the party. Make sure you're the same 906 before. 906, 260. Yep, okay. 346, 425. Okay, get me back. 906, 984. Ooh, you're making a party. Cool. Welcome, welcome. Let me look. 906, 94. Okay, that's the last connection. So according to it, 5, 4, and a bunch of twos. 1, 2, 3, 4, 5. A 2, 2. Lots of twos. And a 4. That's not 4. Where'd you get... Do I go to 11? 10 shortest connections are 11 circuits. 1 with 5, 1 with 4, 2 with 2, and 7 that are single. I have 3 with 2. So either you're supposed to go 1 more, or I can't count. 592, 425. That's a completely new connection. My input wrong. 162 is the first one, 425 is the last. 162, 425, 689, 812. No, I'm doing it right. Let's look at 52, 470, 678, 680, well, 668. Yes. Interesting. Gotta actually read the problem this time, it seems. Okay. 10 shortest connections. 11 circuits. Guess that makes sense. I don't see it. I'm gonna make sure these I'm going in the order. So it's 162, 425, good. 162, 431, good. 906, 805, good. 431, 425, good but moot. After making the 10 shortest connections, I did that. I have my group of 5. I don't have my group of 4. 3, and then I have 3 2s. Interesting. What am I missing? Great thing is it's going to be super obvious whenever I see it. It's not even really close either, at least like these. Maybe it linked to those dots, but you weren't supposed to use those. Nope, that is correct. I don't think I need to do this, but paranoia's got me. At least the groups are actually, to my knowledge, let me look at this. Group of 3, a group of 4, 906, 805, 739, and 984. What happened to 862? 862 into 984. Yeah, 862 and 984. You're also here. Hey, what are you two doing? You two are in the same group. What are you doing? Why didn't you? Okay, so my grouping logic is flawed, so that's something I can easily fix. 52, 117, 819, 941, 346, 425. Yeah, okay. So that's something I can do. I can fix the grouping logic. So for every key, you look. What happened here is groups got built from different directions. So this one got built, and this one got built, so they need merging logic. Okay, so while true, break to stop the infinite. Const A of groups, or const B of groups. If A equals B, of course, continue. If A dot sum, nope. A plus sum of A as A. Congratulations, y'all should be the same one. So just add all of B to A and then delete B. For const bi of B, A dot add bi, then groups, splice groups, index of B, 1, and then this is when you break. Let's see. Merge is false, merged is true. Never merged. Break. So that should make that better. Groups are good now. Unreachable code, why not? Oh, X in the wrong place. There we go. So this should be more accurate. It is. 162. 346. 5422. Okay, I guess that worked. I don't see it myself. Okay, let's clean these up. Actually run for connection count. Where'd that go? There that went. Drop that, and that, and that. And then, what is it? Largest three, multiply them together. The size of the three largest circuits. Okay. Groups sort A, B, A dot size minus B dot size. Largest should be up top. Is that true? Nope, they're the other way around. And B minus A. Return groups slice 0, 3 map size. Back to 11. Oh, I'm supposed to multiply these. What am I doing wrong here? Oh, we're running for real. Cool. Give me my input. So it's probably gonna performance out and die. Oh, nope, got number. Yeah, what am I thinking? This is part one. They're not gonna blow us up the performance just yet. Okay, part two. Keep connecting until they're all in one circuit. Multiply the X of the last two junction boxes you need to connect. Ooh, that's a tough one. Basically, keep connecting until there are no groups. So this algorithm is going to be terribly inefficient. So I need to be keeping track of group as I connect them, not all at the end. That's okay. Hopefully they give one for our example. Okay, my example is here. Good. Great. And then I find original input. There it is. Okay. That's not. Someone's angry. Oh, expected 2 arguments. Yeah, I guess that's a moot point now. No more second argument for you. No, just make connections. This is a while loop. I will insta break, stop the infinite, and we'll do all this in here. If groups dot length greater than 1, or if it equal 1, congratulations, you're done. So that works. That works. Sure. Okay, we have that going. That's going. Yeah, that's not returning anything. The last connection you made that work, it's gonna be right here, A and B. So what specifically? Multiply the X of the last two you needed to connect. Okay. That is return A dot X times B dot X. Now is it working? We're taking a long time. 5. Nope, that ain't doing nothing. Okay, cool, I broke it. It is exploded. Interesting. Well, I don't know why we're getting undefined here. I got a beautiful return. I got a beautiful while true. My breaks are... Ah, oops, I think there's one break. Do I only have one groups? Well, no, that's not what it's meant. Okay, well, that expression is completely failed. If group's length equals 1 and the one group has a size of whatever. There we go. That's more like it. Oh, boxes. Oh, thank you, TypeScript. Great, we have 5. That is failing us. So A dot X times B dot X. This is where the inefficiency kills us. Nope, we can't even run that. So the X's. the last two junction boxes you needed to connect. So apparently it's these two, but I got a feeling for me it wasn't. 162 new. The first that causes it to connect a single circuit, 216 and 117. Interesting. Hold on, also, that's not where that's supposed to go. Oh, everything's wrong. There we go, that's what's supposed to be happening. And now it's running, and the performance is terrible. So that's going to go spinning. And turn 5. Well, actually, let me just drop this to validate it is passing. It is passing. Awesome. Yeah, this needs to be building groups as I go along. So, I'm going to connect A and B. I should just be able to have a lot of this gets moved up and out. So, let's start up here. Okay, we got all the groups. Then once this happens, we make sure those two get together. If there are any two groups with either of them, they get merged together. So, I think it's this logic here twice. For const key of, there we go. Key of go, that's important. Oh, efficiency. That didn't finish, did it? It did give me a big number. Hey, there we go. Solved and done. Okay, which means this is cool, but we're going to time travel a little bit to have our commit in a state that actually solved it. Had doubts, but it actually did the trick. Boom. Okay. Let me add that. Commit away. Awesome. So with that, let's pause all that refactoring and fun stuff, and we will. I didn't. Nope, that's correct. Yep. And let's see what exactly they were asking us for. So, what do they want? They are saying there are a bunch of Christmas lights out here. Well, they're not Christmas lights, they are what? Junction boxes. They give us the 3D coordinates of all the cool junction boxes, and they say connect them together. Now, they tell us to first connect the ones that are as close as possible first. I can't represent this in 2D space, but just the ones that are closest together, connect them first. And for the first one, they say we only have a certain amount of extension cables or a certain amount of connections you can make. For the example, it's 10. For the real one, it's 1,000. So they're saying connect the 10 shortest ones you can, the 10 closest ones. Once you have them all connected, you'll realize that certain ones of them create a grouping, much like over here. Got little groups of them where 162 is connected to 431 and 425, and as coincidence, they were a group without this, but this really makes them a group. Then this is a more realistic group where you got these ones connecting out, this one connecting here, which means the 906 is in the same group as 862. And the last part is they just want you to multiply the top 3 group sizes together to generate the magic number. Part 2, however, is them saying, we have an infinite number of extension cables. You just keep going until you have made one giant grouping where you can go from any one junction box to any of the others. And then they ask us to validate that we've actually done that by multiplying the x coordinates of the last 2 that were required to form the mega group. So they ask, mostly straightforward. I was just fighting with the off by ones. The how, it's graph, so not your basic LeetCode code, but it's also the simplest of graphs, or graph problems, that is. So first thing we do, we gotta do all our parsing. Let me turn off the big input so we can read some of this. Yes, so the first thing we gotta do is our parsing. So we go through all the lines, we split them by new line, so we have a string for each. Then once we have each of these, they look like this, but we want the numbers, so we split by comma, map to a number. And given that I know these are x, y, and z, instead of treating it as a tuple where 0 is x, 1 is y, 2 is z, I destructured them into the variables x, y, and z, and then I returned that as a object with the keys and values of x, y, and z. So that way when I look at a box, it's so much more readable. And we have 20 of them. And then they say they want the 10 shortest connections, or either way, you're connecting the shortest ones possible. So in order to do this, you have to create all possible connections. So this is basically you map from every A to every B. Now, the way I had it before, it was mapping from every A to every B and from every B to every A. So it was bidirectionally mapping, which was not necessary because while from a logistical perspective, you are connecting one to another, it is not a unidirectional connection, it's a bidirectional connection. So it has the same effect as connecting B to A as connecting A to B has for the purpose of the problem and the graph. It's a bidirectional connection. So doubling up on computing all of them, a waste of time, and it hurts the algorithm. So once you have every A and B pairing, I also chucked in the distance between A and B. I just stole this from the internet, obviously. I didn't want to rethink and reread the Wikipedia page for Euclidean distance. I'm not really going to explain it because it's just the math algorithm. Math. And then we have all possible connections, every A to every B, and all the distances. We want them to be the shortest ones first, so we sort them. That does a trick where shortest distance is first, longest distance is last. Then we start building up the connections. So this is a graph where you have the keys is from, the values is where you're connecting it to. So for every 10, you go through the top 10 connections, and we say A is connected to whatever A used to be connected to. So that's getting the previous value, falling back to an empty array, just in case that it was never connected to anything before. And now B. I'm using JSON Stringify for serialization purposes, because keys can't just be a key in JavaScript unless you're using the actual map. Can't just be whatever you want it to be. It has to be strings. So strings it is, and JSON Stringify is a easy and lazy safe way of serializing whatever you want. Then once we've done those 10 connections, we build up the initial groups. This is flawed, unfortunately, but it gets fixed up with the second pass. So this goes to every instance that is connected from something, and it says, okay, are you in any groups right now? If not, congratulations, you have a new group. And then whatever you're connecting to, you're also going to be in the same group. So this does it in the direction of, hey, 346, you in any groups? Nope. Or yes, cool, join this group. Also bring along 425. Or in 906's case, it's like, cool, you're in a group. Bring your friends too. Now, that's flawed because what happens next in what we saw is 862 happens where it's not in a group. So it's like, hey, you need to join a group. Cool, you're in a group. Bring 984 along with you. And now we can see that there are technically two groups with 984. The one that 906 originally made and the one that 862 made. It's in both groups. That is why we have this here, group merging. It's not good, it's not efficient, but like I said, it gets the job done. So it goes through every possible pairing of groups. We didn't even care to get efficient here, so it does a lot more than it needs to. And it says, hey, if any of you two groups have anything in common, you have an intersection, at least that's how you say it in set math. In this case, if you both have 984, you need to join together. In this case, we say everyone joins the first group. So congratulations, you're all part of this group. That other group you had, it's dead now. I deleted it. And this keeps doing that joining until it goes through the entire pairing and it doesn't merge any of them. That means all the groups are actually accurate. Finally, to get the top three, we sort them by size, and then we grab 0 to 3, get the size, multiply the sizes all together. And that's part one. Part two is the same, but going forever. So the only difference is that the first difference, we don't have a for loop, we have a while loop where we just keep going. And every time, so this we already had this before, but now we've put the group calculation logic into the loop, which means every time we try and build up all the groups, and then once we do, we wait until we have a single group, and that single group contains every single junction box. That means we've connected all the things. Now, if we've done that, then A and B are the last connections that we made to make that possible, and we multiply them together to get what they are asking. Like I said, when I ran it, did not expect it to work due to the speed of it, but it did. So, loving that. With that, this is functional, and there are lots of potential improvements to be made. Fair amount of them, honestly. But you know what will make them tomorrow. So we'll leave this like this. I'll optimize it tomorrow before, which will be a little earlier. Then we'll just do the rest of it. So, with that, until tomorrow. Bye bye. I am back and ready to refactor this beautiful code. So let's turn all that on and let's get to it. So let's just start with A and then we will trickle into B. Okay, so we have the boxes, the parsing. Honestly, I like the parsing. That one's good. all possible connections. This one's sufficient. This can be better. Coordinate. And we'll just make this. To a number. Easy win right there. And you know what? I will rename it to point. Point it is. Oh, not that kind of point. Capital P point. You love it. We got it. Okay, connections. These are good. The sorting can be minimized. Does not require a body. Love it. Our connections, they are satisfactory at the moment. They will obviously be getting made better soon. The groups, sorting, the slicing, it's all kind of okay. Let me see what's the commonality between the two. The end condition is the commonality, and what you specifically return. Yeah. So it's how many connections we go for. One of them I'll pass 10 or whatever. The other it'll be past undefined or infinity or something like that. And it's what you specifically return at the end. So I think we'll take. Well, I think I want to start with 2 actually and use this as the base. So let's make that same change over here. Great, they're both identical. Made a lot of changes. And then connections to make number, and then generate answer. This takes something and returns a number. Now what does this take? For you, this takes A and B, but for you, this takes all of the groups. So it's gonna be both. You're going to receive an object containing A, B, and groups. Groups is a set string or an array of a set of strings. A and B are both points. You will do whatever you want and you'll return it accordingly. Yeah, keep having this as a variable. I'll call it state. It's good as name as any. Okay. So while true is technically for I in range of whatever. There we go. For 0. There we go. Drop that, drop that, drop that, drop that. The trick is that when we call it for 2, it'll be infinity. Okay. Oh, I shouldn't have modified solve 2 for this because it's technically the base solve. So let's go up here, make our base solve, and get this party started. So if you hit this, we're going to return, generate, answer, A, B groups. Otherwise, if you reach the end of your loop, return, generate, answer, A, B groups. Now, we don't have that here. We only have that up here. Okay, temporarily speaking, this will go to less than or equal to. And when I reach the end, I'll call this. Which will technically never happen for the infinity, but we're mushing the signature to get this to do what we want. Now, we should be able to call both with this. data, and then it is connection count. My names have changed. Well, actually, I don't need all that. I just need the groups. So I put it into an object so I can pull out exactly what I needed, ignore the rest. And what is it? It's sort and then slice. Where are you? There we go. Slice, reduce, the whole shebang. Boom. Okay, that should be happy for solve 1. We get Quokka actually started again. 50 not equal to 40. Great, I already broke it. We'll make sure. Yep, that works. Okay, which means this is what's failure. Well, what's happening is we're actually going one more than we should. So we actually need to check if you are the last one. And don't go that many. There we go. 50 equal 40. Dang it. So we do this for everyone. We make the connection. What's the difference between this and a 1? 1's down here. It should be identical. Interesting. 1 distance, 2 distance. Okay, broke it. Broke it real good. I mean, this isn't happening, so we're good here. The sorting doesn't affect anything because it's just down here. We actually don't need sorting here. Is this wrong? Let me check what the groups are. Oh, did I just infinite you somehow? How did I infinite you? Oh, are you running on the real data? Yeah, please don't do that. Oh, it's functional now. Great, I guess. Okay, and yeah, this would make sense for the real one. This algorithm, terribly inefficient. That's going to be the last part of the refactor, making this not trash. But we gotta start somewhere. Okay, this works. Let me actually check something real quick, which I should have brought this up earlier. I hope to have the actual correct answer to all this. And there, come back. Oh, hey, what are you doing, Twitch? Come back. Okay, awesome. Hey, look, it's additive code, the thing we're solving. So, correct one for part 1 is this value. So let's get on down here. Awesome, and then let's let you noodle. Did I just break 2 at some point? Oh, because 2's calling. Oh yeah, my new stuff. Yeah, just meant to be broken. Okay, we know this will run eventually. So I'm gonna let that spin. I know it won't run on my Quokka, but it'll run eventually. Great, which means solve 1. Congratulations. Chomp. We love it. Yes, 97384. Good. Yeah, we know 2 is broken. Okay, let's get to a little not broken right now. So you just need to, yeah, accidentally started mutating you into that. Okay. Call the great solve, and then you will need A and B. Because you, oh, that's good also. That doesn't go there. How do you do infinity? Ah, got just a global thing like that. Great, A dot X. Oh, what are you doing? A dot A is a variable. It's right there. Oh, it's you don't realize where you are because I didn't tell you where you were. Great, we got rid of that. A is not defined, except it is. Please stop running the big code. Great, it's a working. Let's trash all of this. We'll put the real stuff on. And we'll make sure we generate the correct values. And put it away. Stop running my clock. So 384 and 096. There's our 384. Round 96 will come. And I can see both are actually getting hit, so that is good. Yeah, very inefficient. We'll get there eventually. And the next part, I believe, is dealing with this heap of a trash pile. Could serialize this. Do they give a range for the values? Because if they do, I can flatten all this into a single integer. They do not. 096. 096. Great. We got it dried out using the same base. Now, these group shenanigans. I think that's all that's really left to do. No more procrastination available. Rename you to points. There we go. Congratulations, you're an array of points. We left you for it. Okay, so what we're doing here is we're building and we keep mushing about. The idea is we just need to lift this out of the loop. Get out of the loop. Technically, so this is what gets out of the loop, and then when you're adding a new connection, we need to make sure we're just adding these two. So the only key we're looking for in connections is, I think I started to do this over here. I didn't save the code. Why is that over here for? Okay, well, I just have to do this myself. Oh my gosh, please stop that. JSON A. You didn't even do the. Okay, good enough. So for key and connections, this is the new key. It's JSON A. And then we're putting in the extra bits, which is JSON B. That's it. That's all the new parts we're putting in. Now that in itself should be terribly, like, much more efficient. Unless I've completely forgotten something and this is just ain't no work no more. Yeah, we have the adding, we have the merging. Why no work? Okay, well, it was a really good thought. Do we need all of your friends? I was just being lazy and only touching the new one. New. Okay. Time to understand where we went wrong. The heck is that? What is that? Don't do that. Oh, I did in, so that went keys instead of values. There we go. There we go. Everyone's happy again. Okay. Watch how fast it's going to be. Well, that's okay. Look how correct it is, though. Okay, so this is better. We're still doing this terribleness of an algorithm. I think that's my main pain point right now. You get a new key, a new connection between two new things. You make sure to squash groups. Make sure everyone gets added to their friends. So I think I can just drop that. Yeah, let me in there. There we go. That group is, you add the one you're connecting to, make a new group. This is satisfactory. Okay, that part is good. This part needs some loving. I think we do the same thing we do up here with the indexing. Now, entries is an expensive one, so paying a price here. AI plus 1 allows us to not do that. Any of those, yeah, intersection. We love intersection. That's better. Is it good enough, though? Fans be spinning. No. I won't necessarily go for the most optimal here, but I do believe I can get this better. I know JSON stringify ain't cheap, so we can look into a serialize. It's going to be the same work, but just not run through full-fledged JSON. And I will destructure that and make this real easy. X, Y, Z. Yeah, wrong place. Whoop. Y and Z. There we go. Well, U can be used accordingly, like so. Oh, I missed it. Okay, that is a little better. And then this doesn't need to be a loop anymore, so you can say goodbye to that. Awesome. The merging algorithm, probably the most expensive part, honestly. But I think I have the logic here. So breaking this, we can also break this. If merged break. Yep, don't run, don't run. Okay, I'm feeling better. Well, you can actually technically keep going, ain't gonna hurt, but I think it's more efficient this way. Groups index of B, we can, well, the offset's gonna be AI. Let's still make it more efficient. And then, there we go. Now this is gonna be wrong, but it's AI plus BI. Would that get us where? Plus 1. There we go. Love our offsets. So 1 belongs to you, actually. Oh, don't delete that. Okay, that's better. Yeah, add all of them to there. Delete the other one. That's not a good naming. Point of B. There we go. Add them all to B, add them all to A, get rid of them. This ain't cheap. But this is also efficient. Is it expensive enough not to want to do anymore? Oof. It's struggle buses. Very fast though. Oh, and actually was able to run in clock at some point. Okay, so we are getting better. I really cared about performance. I start cracking out the profile, heat graph, and all that stuff. I'm not gonna go that far. This is efficient. We want that. This is where we lose our efficiency. I mean, instead of converting to array, I can just for loop this. Makes it more gross, but more accurate. Let's just do that. Const sets share a value equals equals a set t b set t. I don't think I put this in the right place. That will help. Awesome. For const a value of a if b has a value turn through. When I need to do it the inverted way. No, if any are intersecting, that would suffice. Now, the efficiency here is that I'm not converting these back to an array to answer this question. So this should be great. A, B, and drop. Boom. Same. All still works. Okay, now I know these entry calls, these slice calls, not efficient. So if we still have a little spin on it, better. Let's try and get scientific. Yeah, practically none. So 3.4 seconds. 3.5 seconds. Sample size of 3 should be okay. 4, 5, 6. Okay, so sample size 3.5. Let's call it that. So even though this does the same thing here, this is a once operation, so I am going to ignore it. For let AI equal 0, AI less than groups dot length, AI blush blush. A equals groups AI. Boom, that one is done. Let's do the same for our B friends. This one starts at AI plus 1. Ah, escape, let me out. And that is it. Why does this not work? What have I done here? Did I not rename something good? Maybe didn't you where you should be. What did I do? BI equals AI plus 1. Yeah, that's what I did. B is groups B. What did I do wrong? What's wrong? What did I do? Well, this is quite terrible. I guess I'm going to put a return statement here. Whoa, not reduce each trailing comment range. Okay, what is A? A is a thing. What is B? B is a thing. AI and BI, yeah, they're things. Did I? My helper was working before. It's not my helper, is it? No, this works just fine. What infinite loop did I walk into? Slice AI plus 1. Entries. Ooh, this math here. Yeah. You can just now target BI directly. Okay, there it is. Okay, we have 3, 4, 3, 5, 3, 6. What do we got now? Do I still have one up here? No, I don't. 3, 8. Great, it got slower. That's what you get for macro optimizing and not even doing it scientifically. 4 seconds? Well, I don't really care. I like mine now. It's more readable. And we need B multiple times. We need A multiple times. Okay, yeah. Makes sense. If set share of value, add them all. Marker merged, break. Makes that loop. If you merge something, break. You know what? You don't need to do, well, when doing this, you actually will. But we can actually make that optimization. Boom. So this actually keeps going a little bit further. See if we can find any more groups. One group and the size, good. If you're the last one, good. Let's drop all of this. Rename this. Merged group. Now, I have a while loop doing this, but now that I'm incrementally adding them, I don't know if I need a while loop doing this. Yeah, I'm gonna stop that because performance ain't gonna make it. So let's see if I can drop the while loop. Because if you connect two things, at most, you will merge a single group. You can't merge 5 groups by making one connection. There we go, which means you can drop all of that. Once you make the merge, you can stop both loops. Ooh, it's kind of cursed. Well, I've not used a JavaScript label in forever. There we go. It breaks this loop and the outer loop. Not really recommended. It's in the go-to category of constructs, but it works, so who cares? We need the A there, we need the B there. Okay, so we need them in both places. Can't do nothing about that. Connections. What's the point of connections? Boop. We don't need connections. We have groups. Awesome. Which means these values still need it twice, except this one down here. You can go right in there. Awesome. I am seeing. Okay, I was about to say I saw multiple operations. New. So I have them as string, I convert them to points, and then for every other interaction of them, I convert them back to strings. Let's quick sanity check on my input. Okay, I was about to suggest finding the largest value, collapsing this all to a single integer. I don't think there's a lot of value in doing that. I think for this, though, we do want to calculate the distance. So A, B, what if I just didn't do this? I had them as strings. Then I converted them out right here. That would eliminate that and eliminate that. Let's go for it. I wouldn't need serialize. I really need deserialize. Nope. I think I'll do this in the caller, not here. There we go. Satisfactory. Love it. And then you just gonna do this right here. Ooh, this does do a lot of work, especially on the B half of this. So I do want all as points at some point. But then down here, I don't really want them as numeric. Okay. I was trying to go for, if I have to keep ping ponging between them, it's worth the price without ruining the readability for a slight boon of efficiency. Okay, that's good. So if you have it, boom. If you don't, congratulations, you got it now. A group, B group, the merging only needs to happen once. It's the only possibility. Yeah, don't even need to do that anymore. You can just be done with this. I could shove all this logic into a update groups function. Possible connections. I do need this. Do I need the I? No. Okay, I need this to detect the last one. I do need it. Never mind. I was about to just make this a for loop over that. But you can't. I'll give this a type so that way it's at least typeable. Not a pipeline transform. Boom. It's a little bit better. A little bit prettier. A little bit grouped better. And I'm going to call this done. I'm not sure it still works. That it does. All refactored and cleaned away. And with that, I am done. See you next time.